This first technique is called TP timer insertion, which is just it's another process injection technique on top of the many ones that already exist. It's pretty unique because it allows you to inject into another process without the creation of a thread, which is a typical indicator of compromise or often used to determine whether or not a process injection attack is occurring. So within the course, we go over all the code and everything about how it works. I'll be demoing the loader that we've created in the course that uses this. So I'm gonna go ahead and first I'm gonna make sure that I have Sysmon running. Sysmon is a tool that defenders use to obtain some telemetry. It registers information within and logs it within the kernel, just like how a lot of EDR drivers do. So it effectively is our sort of simulation of the visibility that an EDR may have on the tooling that we use. So I'm making sure to log thread creation events, and I'm gonna go ahead and make sure that I turn on Sysmon first. Okay. And within the Windows event viewer, I should be able to see that there is Sysmon operational logs now. Now, the particular event ID we're interested in right now is going to be event ID number 8. That one is what indicates that a remote thread has been created. I have Cobalt Strike open right now, no callbacks. And I'm going to now run our our TP timer injection tool. And the process I'm injecting to is Notepad, which has PAD 4112. So I should be able to run it. And I see that we've received a callback from the beacon. And if I go ahead and check, there is no event ID number 8. So this is really convenient for us because we're able to still get the same effectivity of a process injection. So we get to move our beacon to a different hosting process, but there's less indicators of compromise, at least traditional indicators of compromise. The way this injection technique sort of works is rather than explicitly creating a thread, this technique ends up creating what's called a timer object, and timers can execute a function upon their expiration. So what we do is we're going to create a timer and we're going to write it into a remote process and basically trigger that timer after we link it up with the remote process's timer queue. That's why it's called sort of like TP timer injection, because we're creating a timer. We write the timer in, link it up, and trigger it. So that way, um, the thread creation happens on the other process's end rather than us explicitly creating it. And we could see that's happening here because, well, there's no event ID number 8 coming from our process. Let's contrast this with something more traditional, like a create remote thread injection. So once again, we're going to be targeting process 4112, which is Notepad. And if this is going to build this, just in case it's not already built. And if we go ahead and run this, it's going to spawn calculator rather than spawning a beacon because that's just what the shellcode we are injecting does. That shellcode also ended up crashing the Notepad process, but we check Sysmon, we should see there is an event ID number 8 coming from our create remote thread binary, and it shows the memory address and other arguments that got passed into it. So a lot of traditional techniques will have this sort of indicator compromise where you see a thread creation event within a remote process, and that's not very ideal. So what makes TP timer insertion a little different from another technique like, say, early bird, which also avoids the remote thread IOC, is that early bird injection requires an explicit process creation that's suspended, whereas TP timer insertion, you could just insert your timer into any process, since all processes have a timer queue, which makes it really useful and really effective. This technique was also created by a group called Safebreach Labs. So there goes our beacon. And